Now that you are confident with solving for missing angles and missing sides using SOHCAHTOA, cosine law, and sine law, we can use these methods and apply them to application problems or real-world scenarios. So first we are going to look at how to solve word problems using SOHCAHTOA. If you recall, we can only use SOHCAHTOA with right angle triangles. So that means that these word problems will be scenarios that involve one or more right angle triangles. The first definition that we need to know to be able to set up and solve these diagrams is the angle of elevation. The angle of elevation looks like this if we had a horizontal line and then we had another line almost directly on top of it. We could picture the angle of elevation as opening from the horizontal up as so. And that, if we labeled that theta, this would be the angle of elevation. Okay, so we can think of it as the angle between the horizontal and whatever else, like the other line is. It could be a line of sight, it could be a ladder, it could be a string, a wire, depending on the scenario of the question. Okay, but you always start from the horizontal. So when you see this part here, what type of line must be part of these angles? A horizontal line must be part of them. Okay, so sometimes the horizontal is the ground. Oftentimes it is. Sometimes it is an imaginary horizontal line that we draw. It just depends on the scenario, and we'll look at a few examples on how we can set up the diagrams. Okay, so that is the angle of elevation. So that would be something like if you were on the ground and you said the angle of elevation from where you're standing to the top of a house is 40 degrees. That would mean if you started from the ground as your horizontal and you created that line that opens up from the ground to the top of the house, the angle there between the ground and that line, your line of sight from the ground to the house would be 40 degrees. So an angle of depression is similar in the sense that it always starts with a horizontal line as well. However, instead of opening up like we did before, if you think elevation, makes you think up, depression makes you think down. So instead of opening up, it would be like if we started from the horizontal and we opened down, down, down like this, and the angle was here. Okay, so this is the angle of depression, and it is from the horizontal opening down. Okay, as you practice with diagrams and practice labeling triangles, you will become more confident with drawing and putting the angles in the correct spot. Okay, the angle of elevation is pretty straightforward for where it goes, but oftentimes, depending on the diagram, the angle of depression will get put in an incorrect spot. So we will take a look at some examples to make sure that we're confident with how to solve this. So this first example here has the diagram already drawn for us, so we don't need to worry about setting it up. We will look at one of those later. But this question says the angle of depression from a building to the ground is 38 degrees. So in my diagram here, I've got my building. This is the building that I am using as my reference point. And I'm saying the angle of depression from that building to the ground is 38 degrees. Okay, so we said that an angle of elevation or depression always needs to have a horizontal. So in this case, there wouldn't actually be a line here, right? Because this isn't the ground. But you see this dotted line here. This is an imaginary horizontal line that is level with the top of this building. And we're opening down because it's an angle of depression, which means that the 38-degree angle is here. Okay, a common mistake if you weren't given the diagram would be to put 38 degrees here. However, that is not where the angle of depression is. Okay, it always needs to be between the horizontal line and your slanted line. Okay, then the next part of the question says the angle of elevation from the same building to a taller building next to it is 52 degrees. Okay, so from this same spot on this building, we're using the same horizontal line because our reference point is still the same. The angle of elevation, so opening up, is 52 degrees. Okay, so then the other piece of information that we know is that this building here, the shorter building, is 42 meters tall, and we are trying to find two things here. The height of the taller building, okay, so how tall this building here is, as well as the distance between the two buildings. Okay, so I usually like to show in my diagram what I'm trying to find just so I can make sure that I know what I'm looking for, and it's just nice so that you can see it as well. Okay, if I give you a diagram on the test, there will be some questions where I give you the diagram and some where I ask you to draw them. You just need to make sure that you are labeling them correctly. Okay, especially if I give you the diagram, I want to make sure that you are putting labels in place so that I know what you're talking about when you are solving things. So this is one of the things we are finding, right? This is the height of the taller building. I'm just going to label this as H so that I can use a variable when I am solving things in my equations. And I also want to know the distance between the two buildings. So for that, I'm going to put a label here. Okay, this would represent the distance between my two buildings. And something I can keep in mind here is that this, I'm going to call it D for distance. This line would be the same as this line. Okay, so that's what those two blue lines there mean. That means that that both of those horizontal lines are the same because we can see here if we were to draw like connect lines here, this makes a rectangle, and we know that the opposite sides of a rectangle need to be equal. Okay, so now that we know what we are solving for in our diagram, we need to figure out how we are going to go about solving that. So if we look at the diagram here, we have a right triangle here, we have a right triangle here, and although it's not necessarily labeled with a line across the bottom here, there is another right triangle here. So what I'm going to do is I'm going to take the 42-meter height of the smaller building, and I'm also going to write it here because, again, it makes a rectangle if you look at where the shorter building is. So we know that this portion of the taller building, or just this side of the bottom right triangle here, is 42 meters as well. And what I'm going to do is I'm going to look and see in this triangle, what do I have? So I have one of my acute angles, and I have a side length, which means I can use SOHCAHTOA to find the missing side. Okay, so the missing side that I want to find is going to be this one. Okay, the hypotenuse here is of no use to us. We don't need this for anything, so that is not helpful to find. But if I find this side here, it will accomplish two things. One, it will tell me what the distance between the two buildings is, and two, it is the shared side between this multi-triangle diagram, so I can then use that to find what I need to figure out the height of the taller building. Okay, so first I'm going to label this triangle so I know which sides I am working with. So 38 degrees is my reference angle, so this is opposite. My hypotenuse is here, and my adjacent is here. And I'm just going to label my solution here so everything is clear. My first step is going to be find side D. Okay, so side D is labeled obviously down at the bottom there, but it's the same as the one within the triangle that I'm finding as well. Okay, so I'm going to write which side I have, which side I want. Because I am working with the right triangle, I can use SOHCAHTOA. So I have my opposite side. I want my adjacent side. So if I take a look at my acronym SOHCAHTOA, I am deciding which one to use based on the one that uses opposite and adjacent. And in this case, that would be tan. Okay, tan uses opposite and adjacent. So I'm going to set up my equation using those two sides. So I will write tan of 38, okay, that's the angle I'm using, is equal to my opposite side, which is 42, divided by my adjacent side, which I'm going to call D, okay, because it measures the same as the blue line that I have labeled as D. Now I just need to rearrange, isolate to solve for D. So I'm going to multiply by D on this side, multiply by D on this side to cancel out the denominator here. Okay, then I have D times tan 38 is equal to 42. And then I'm going to divide by tan 38 on both sides to fully isolate for the measure of D. Okay, this will cancel out here. And if you type that in on your calculator, you should get 53.8 meters. Okay, again with side lengths, you only need to round to one decimal place. If you prefer to keep a few extra decimal places right now, and then round at the end, that is fine as well. Your answer will just be a little bit more accurate than what mine is. So we know that the distance between the two buildings is 53.8 meters, so that answers part of our question. And now we need to figure out what the height of the taller building is. Okay, so if we look at our diagram, the height of the taller building is obviously this entire side here, or if we were looking within the triangles, it's this part of the top triangle plus this part of the bottom triangle, which we already know is 42 meters. Okay, so because we already know part of the height of the building, we need to figure out what this height is of the top triangle. And we do need to set up a ratio to solve this. A common mistake that I see, or an assumption that I see often, is that people will say, okay, well, if this is 42 here, doesn't this just look like it's 42 as well? Isn't it just double it? However, you cannot ever assume measurements or whether they're angles or sides based on how the diagram looks. Okay, the diagrams are never drawn to scale, so the only time you can ever assume that something is equal would be if there was something like this where the line is telling you that they are equal, okay, or I would state it in the question. So if there were, let's say, like a line here and a line here to show you those were equal, then you could assume they're both 42, but they're not. So I'm going to label this top triangle in reference to the 52-degree angle. It's a right triangle again, so I'm labeling opposite, adjacent, hypotenuse. So this is my opposite, this is adjacent, and this is the hypotenuse. And like we said, we want to find the opposite side because that's going to tell me what that top part of the height of the building is. So I'm just going to call that x so that I have a variable for it in my solution. Okay, so step 2 is going to be find side x. And again, I'm setting up a trig ratio. So although it's not labeled in my triangle, I have my adjacent side. Okay, because I found the adjacent side in the blue triangle, it's the same because it's the shared side. So I have my adjacent and I want my opposite. So again, that's going to be a tan ratio, okay, because it's using the same two sides. The only difference here is that it is going to be set up with the unknown in the opposite spot. Okay, so before we had our unknown in the denominator, now it will be in the numerator. Okay, so I'm going to set up tan of 52. Make sure you're paying close attention to which angle you are using, just depending on what question or which part of the question you're solving. So tan of 52 is equal to opposite, which is x, divided by adjacent, which we calculated to be 53.8 meters. And this one, because the unknown's on top, to isolate, it's pretty easy. We're just multiplying by 53.8 here to cancel out the denominator, multiplying by 53.8 on the other side as well. And if you kept your answer on your calculator from part 1, then you would be able to keep it to be a little bit more accurate. But again, it's fine if you round it in between. And then I'm just going to put x here for my solution just because I like it to be on the left side. But what I'm doing is 53.8 multiplied by the tangent of 52 degrees, and I get approximately 68.9. Okay, again, I'm rounding to the nearest decimal place, 68.9 meters. Now, I need to make sure that I have fully answered my question. So I'm looking back at what the written part of the question says to confirm if I have fully solved it or not. So it wanted me to determine the height of the taller building and the distance between the two buildings. So I've determined the distance between the two buildings here, but I have one more step to find what the height of the building is. So I'm going to just show that here briefly. So my last step is to find h, which I had labeled as my height. And to do this, it's just simple addition, right? We can see from the diagram that the height of the taller building is equal to 42 meters, which is the height of the shorter building, plus x, that side that I just found, so 68.9. So that tells us that the height of the taller building is 110.9 meters. Okay, so some important things to keep in mind when you are answering a word problem. The math is the exact same as what we've been practicing the last few days. Okay, so the equations that you're setting up are the same. The way you calculate is the same, right? You'll either be using SOHCAHTOA, sine law, or cosine law, just depending on the type of question. The key things you need to make sure that you are including are the units. Okay, so in this diagram, I showed you here that the units were meters, and also in the question I told you the units were meters. So because I'm solving for two different side lengths, two different distances, I need to include meters in my solution, okay, just for some, like for full communication marks. And because it is a word problem, meaning my question is posed as kind of like a paragraph, a few sentences together, I need to provide a sentence answer. Okay, so you may or may not have seen this before, but what I'm going to do is I'm going to write this little symbol. It's like 3 dots that kind of make a triangle. This means therefore, and I'm going to say therefore the taller building is 110.9 meters tall, and the two buildings are 53.8 meters apart. Okay, so just make sure that you put a clear sentence answer for a word problem so that you can fully answer the question. It's just, again, part of good communication marks, and on your test there will be communication marks, and that includes rounding, providing a sentence answer when necessary, and including units in your solutions. With some word problems, you will be required to draw your own diagram. Okay, so we saw in the previous example that when the diagram's given to you, it's pretty easy to see what is being asked of you, to interpret the question, and to solve. But we also need to know how to interpret the question without a diagram given and set one up ourselves. So this question is similar to the last one, although it is a little bit different. So it says Tammy is standing on top of a short building. Her eyes are 5 feet above her feet. There is a taller building across the street 50 feet away. She looks up at an angle, a 43-degree angle of elevation to the top of the taller building's roof, and she looks down at an angle of depression of 66 degrees. We want to know how tall each building is. So from just the initial read through of the question, it can seem like that's a lot of information that's kind of confusing. So I like to go through and kind of pull out the important information, which typically is the information that has numbers with it. So we know there are two buildings in this scenario. There's a shorter building and a taller building. The distance between them is 50 feet. We also know that her eyes are 5 feet above her feet, which I know sounds funny, but I'll show you what that means in a moment. She's looking up at an angle of 43 degrees. Okay, that's her angle of elevation. And the angle of depression is 66 degrees. So when you're picturing this, just try and picture what would this look like in real life, and that will help you get started on drawing your diagram. Typically, most of these things we're setting up will be something that is standing on the ground, especially if it's a SOHCAHTOA problem with a right triangle, because we need to have those two perpendicular lines making the right angle triangle. So buildings are obviously on the ground, so I'm going to start just by drawing a line like this to represent the ground. Now, we know there's a shorter building and there is a taller building. So let's say I'm going to draw a building here. This is my shorter building. And this is also the building that Tammy is standing on top of. And there is a taller building across the street. Now, obviously, when you're drawing this, your diagram is not to scale. So just label everything how it should be, but you don't need to try to make it look perfectly to scale. I'm not marking your artistic abilities. I just want to see that you can understand the question based on what is being stated for you. So we've got the ground, we have our two buildings, and whenever we're dealing with like a building on the ground, a flagpole, a tree, anything that's like a vertical object on the ground, we can assume that it is 90 degrees. Between them, okay? Unless the building is the Leaning Tower of Pisa, then it will be perpendicular on the ground in theory. So that is just always an assumption you can make when setting up these kinds of questions. Okay, so that's a right angle as well as on the other side. I'm just not going to show that right now. Then we have Tammy. She's standing on top of the shorter building, so I am going to draw her here. There she is, standing on top of the building. And the key piece of information that we're given here is that her eyes are 5 feet above her feet. So what that means is that when she's standing, if you measured from her eyeballs to where she's standing, it's 5 feet. Okay, so she's obviously a little bit taller than 5 feet, but that's where her eyeballs sit in relation to the ground. So before I draw that measurement, what I'm going to do is I'm going to draw a horizontal line here because I know that I need to work with a horizontal line since I have an angle of elevation and an angle of depression. And in this case, my horizontal line is going to be imaginary, similar to in the last question, and it is from her eyes horizontally across, and I'm just going to stop it at the building there, just for the sake of the diagram. Okay, so from where she's standing on the building to that imaginary horizontal line, that's not quite in line, but you can get the gist of it here. 1 second. If I were to draw this, oops. Okay, that's actually in line there. And have this height labeled here. This is 5 feet. Okay, I'm also going to label, I forgot to do that before, but this here, the distance between the two buildings is given as 50 feet. Okay, so I'm going to put that here on the diagram, and I'm going to just go through and put my last few pieces of information. So it says from where she's looking, so she looks at the angle of elevation. We're using her eyes as the point of reference because that was stated for us in the question. Typically we just use the ground, but from her eyes, the angle of elevation to the top of the taller building is 43 degrees. So that means from the horizontal opening up, right? So like this is our horizontal, we're opening up. Obviously, like I said, this is not to scale because that angle is clearly not 43 degrees, but that would be 43 degrees here. And she looks down at an angle of depression of 66 degrees. So we're using the same horizontal line there because again, it's from her eyesight is the reference point. And because it's an angle of depression, we are going to start from the horizontal and open down. And the wording of the question isn't quite specific, but we can assume that she's looking down to the base of the building. Okay, and angle of depression means it's opening this way, so this is 66 degrees. And again, because we know that the building is perpendicular with the ground, we can also say that this here is perpendicular. It's a 90-degree angle. So similar to the previous question, we have two right angle triangles that are in the diagram here. And the last thing that I'm going to do is I'm going to just label the pieces that I'm trying to find. Okay, so I'm trying to find this, which I'm going to call X, right? I want the height of the shorter building. I want the height of the taller building, which I'm going to call Y. I'm just going to show here that that's what I'm looking for is the height here. And X is this. Now, I need to figure out how I'm going to solve this. So, similar to the diagram before, I've got a right triangle here, I have one here, and I have one here as well. And I need to look and see, okay, which one do I have information for so that I can solve that first. Now, I've got the distance here labeled as 50 feet. I can say for sure that that distance is the same as this side here, right? Because again, it makes that rectangle there. So this, I'm just going to label, actually no, it's a little bit crowded. So, but that side there's 50 feet as well. So if I'm looking at either of my right triangles, if I look at the top one, I've got an angle and I've got a side, so I can find a missing side. And in the bottom triangle, same thing. I've got an angle and I've got a side, so I can find, again, another missing side. So what I'm going to do is I think I will start with the bottom triangle. So I'm going to label my sides. I'm going to just put a little dot here so you can see which angle I'm working with, or I'll highlight it here. So I'm going to use blue for the bottom triangle here, and I'm labeling my sides. So this is the opposite, this is my adjacent, and this is my hypotenuse. And I'm trying to figure out, okay, which side do I want to find? Now, in this case, the hypotenuse again is useless to me. I want to find the opposite side. Okay, the opposite side is not quite the answer I'm looking for, because in the taller building, it's going to be just part of the height. But if I find that, I can use it with this side as well once I find that to find what Y is. And if I find this, then I can use that to help me find X, the height of the smaller building as well. Okay, so I'm going to just label this as well so that I can know what I'm solving for when I'm writing my equation. I might just call this H as this side in here. Okay, so my first step is solve side H. I'm going to use SOHCAHTOA because it is a right triangle. So I have my adjacent, I want my opposite. Just for the sake of space, I'm not going to write my acronym SOHCAHTOA, but it's the same one that we used above. Opposite and adjacent is going to be tangent, so I'm going to set up tan of 66 degrees is equal to H over my adjacent, which I said is 50. Okay, then to isolate it, I'm just going to multiply by 50 on both sides, and I will have that H is equal to 112.3 feet. Okay, so that's one piece of information solved. You can see that I skipped kind of quite a few steps, which is fine. Honestly, that's enough information for you to show for a test or any questions that you're handing in, especially when you've got limited space. But the way that I'm solving is the exact same as what I showed you in each of the initial lessons. So if you prefer to show more steps, that's fine as well. Then I want to find the side of my upper triangle, so this one here. Again, I'm going to give it a label just so I can know what I am solving for. I might just call this one, let's just call it A. And it's a right triangle again on the top there. Okay, so I'm gonna just highlight this so we can see which triangle I'm labeling for, and I'm labeling opposite, adjacent, hypotenuse. Okay, so this is my opposite, this is adjacent, this is hypotenuse, and again, obviously I'm trying to find the opposite. So the way I'm setting this up is pretty much going to be the exact same as what I just set up for the bottom triangle. Okay, so I'm solving side A. It doesn't really matter what you call your sides when you're doing this, as long as you're labeling them clearly in the triangle so that when you say side A, I know what you're talking about. So I have my adjacent again, I want my opposite. So the thing I'm setting up is the exact same. The only difference here is that I'm changing the angle to 43 degrees because this side is now part of my top triangle. So this is equal to A over 50. And then same thing as what I just did above, I'm multiplying by 50 here, multiplying by 50 here, and that will tell me what that top part of the triangle is. So 50 times tan of 43 degrees is 46.6 feet. Okay, and now I have enough information to solve for what I'm actually looking for. Okay, so when you're doing these types of questions, make sure you are continuing to go back and reread the question so that you know that you're solving completely or actually finding the right thing. So I want to know, how tall is each building? So both of the heights of the buildings, those are not actually any of the sides of my triangle, but because I just found the two sides, this one and this one, I can find the heights of the two buildings. So my third step here, I'm going to find the height of the shorter building. So I'm going to find x. Now, if I look at my diagram, I'm going to just show this in pink so you can see it here. X is this part here, okay? But X on the actual diagram here in relation to H is only like this part here. Okay, so when I found H, this here, and I said that that was 112.3 feet, that is from the top of Tammy, or sorry, not even the top of her, from her eyesight to the ground. So to find X, what I'm going to do, I'm going to say X is equal to H, right, that height, that side of the triangle that I found, subtract 5 feet, okay, because that's the 5 feet from Tammy's eyesight to her feet. Okay, so we'll say X is then 112.3 subtract 5. Okay, so X is 107.3 feet tall. And then lastly, I want to find the height of the taller building. So step 4, I'm going to find Y. And I'm looking again at my diagram. Y is here. And Y is made up of H and A. So I can just say Y equals H plus A. Sorry, my stylus is not wanting to write very nicely. H plus A. So I'm going to do 112.3 plus 46.6. And that tells me that my height of my building is 158.9 feet. Okay, so now I have fully solved what the question is asking me to find. I have found the heights of both buildings. And lastly, because it's a word problem, I need to write a sentence answer. I don't have a ton of space here, but I'm just going to write it here. So again, these little 3 dots, this means therefore, and I'm going to say therefore the shorter building is 107.3 feet, and the taller building is 158.9 0.9 feet. Okay, so like I said, the math is the exact same as what we've been practicing, but reading the question and interpreting it to make a diagram is the new piece here, and practice, as always, is the way that you will learn it best. And yeah, the math that you're setting up will be the same.